Hello viewers. Welcome to the YouTube channel. In this video we will discuss last 2 days physics strategy. About the most important 3 marks and 5 marks questions of Chapter 8, Electromagnetic Waves, Chapter 9, Ray Optics and Optical Instruments. And Chapter 10, Wave Optics. For Class 12 or PUC 2 Board Exams 2025. This will help you to pass and score in the board examination. So watch till end, and just do one like, share and subscribe. If you want a PDF copy, just visit description box for PDF link and comment your review. Let's start one by one. Chapter 8, Electromagnetic Waves. 1. A. What is displacement current? Give the expression for it. B. Mention the need for displacement current. 2. Write the expression for Ampere-Maxwell's law. Explain the terms. 3. Who predicted the existence of electromagnetic waves? Give the wavelength range of EM spectrum. 4. A. What is the source of electromagnetic waves? B. What is the nature of electromagnetic waves? 5. State 2 characteristics or properties of electromagnetic waves. 6. Mention the expression for speed of light. A. In vacuum. B. In a medium. Explain the symbols. 7. Give the wavelength range of A. Microwaves, B. Infrared waves, C. Ultraviolet radiations, D. X-rays, E. Gamma rays. 8. Give any 2 applications or uses of A. Microwaves, B. Infrared waves, C. Ultraviolet radiations, D. X-rays, E. Gamma rays. Chapter 9, Ray Optics and Optical Instruments. 1. A. Derive F is equal to R by 2. B. Derive the mirror equation in the case of real and inverted image formed by a concave mirror. 2. A. Define critical angle. B. What is total internal reflection? Mention the conditions for total internal reflection. 3. A. Mention 3 applications of total internal reflection. B. Write the principle and 2 uses of optical fibers. 4. Obtain an expression for the refractive index of the material of the prism in terms of the angle of the prism and angle of minimum deviation. 5. Obtain the relation between U, V, R and N for spherical surface. 6. Derive lensmaker's formula. Name 2 factors on which focal length of a thin lens depends. 7. Define the power of a lens. How does power of a lens related to its focal length? 8. Derive the expression for effective focal length of 2 thin lenses kept in contact. 9. Draw a neat labeled ray diagram, with arrow marks, of a simple microscope for the image formation and write the expression for its magnification when the image is at near point. 10. Draw a neat labeled ray diagram, with arrow marks, of a compound microscope for the image formation and write the expression for its magnification when the image is at near point. 11. Draw a neat labeled ray diagram, with arrows, of A. 1. Reflecting telescope, 2. Refracting telescope. Chapter 10, Wave Optics. 1. Define wavefront. What type of wavefront obtained from? 1. A point source, 2. A line source, 3. A star. 2. State and explain Huygens principle. Derive Snell's law of refraction using Huygens principle. 3. Show that angle of reflection is equal to angle of incidence using Huygens principle when a plane wave incident on a plane mirror. 4. Give the theory of interference. Hence write the conditions for constructive interference and destructive interference in terms of 1. Phase difference and 2. Path difference. 5. What is interference of light? Briefly describe Young's double-slit experiment. 6. Derive the expression for the fringe width of interference pattern in Young's double-slit experiment. 7. What is diffraction of light? Describe diffraction of light at a single slit. Give conditions for minima and maxima. 8. Give the graphical representation of the distribution of intensity on the screen in case of 1. Young's double-slit experiment. 2. Diffraction at a single slit. 9. Give 5 differences between interference and diffraction. 10. Define resolving power, RP, of microscope. Write the expression for it. Mention 2 methods to increase RP. 11. Define resolving power, RP, of telescope. Give the expression for it. Mention 2 methods to increase RP. 12. State Brewster's law, obtain Brewster's law or show that refractive index of a material N is equal to tan IB. 13. A. Coherent waves of a constant phase difference undergo interference. Obtain the expression for the resultant displacement. 3 marks. B. Write the conditions for constructive and destructive interference in terms of phase difference. 2 marks. This ends the most important questions from Chapter 8, 9 and 10. Don't forget to subscribe the channel for more updates.